Yeah, and just wanted to go over one of these equations and how I was actually really impressed with learning how to conceive an argument for antimatter. So just going through it, you have d multiplied by time over time multiplied by, that is the particle electric effect, you'd say, of acceleration. It's also the orbital, the electron orbital, and you multiply that by the frequency times the length, and you divide that by the frequency times distance times the quantum. Like, I was just calling it the quantum because I'd call it the quantum measurement of particles or bits times acceleration divided by distance multiplied by time. So you can understand that this sequence of this extremely in-depth math problem, this sequence is happening. It's happening as a sequence of events. So the distance, the distance could be so many things. The distance multiplied by time, okay? The distance multiplied by time could just be for when the three bodies were observed. So that's why this is a very interesting problem, like E equals mc squared. I'll kind of get to that point, but I mean, my point is E is not just energy, by the way. It's polarization, and it can also be, energy is the polarization effect, I should say, and it can also be, it escapes me right now, but so that's my point. F equals ma, E equals mc squared, ke equals 1/2 mass velocity squared. These are all very sort of short problems, but if you think about a problem like this, because you're supposed to be able to apply those problems to artifacts in the universe, and so to do that to the three-body system of the sun, the moon, and the earth with a problem like this, you understand that so much is happening, like the time moving through the galaxy, the speed of light, the distance traveled. The problem is the antimatter is what's happening while you're solving the problem. It's almost like that. But I like it. I do. So yeah, division, the frequency multiplied by the distance of the quantum. I'll just call it the quantum because it's the quantity of atoms and protons, neutrons. So you'd have to have a specific. You'd have to have like have some code or something to be able to tell a computer, like, this is exactly how many, or whatever. This is how many atoms and all that stuff from this distance and that distance are. But we can't figure that out, and there cannot be a deterministic value to it. So that's kind of sad. Anyway, and then you multiply that by the frequency of and then multiply the quantum, and then multiply the acceleration, and you multiply all of that by distance times distance, multiplied by times, divided by time. You get another alpha fold. It's called alpha folding. This wasn't an alpha fold. This was not an alpha fold problem, but this was a very complex problem. But you could probably go through it and think about it and say, like, oh, okay, the sun's here, it's moving through the galaxy. The moon is orbiting around the Earth and all that. But yeah, the summation of this all is that it just doesn't equal zero. It doesn't equal zero. So, because the thing is, it's going to be a very small. I mean, she's just saying she's just saying it doesn't equal 1, but it doesn't equal 0. It doesn't equal 0. You know, this was like the trouble of it. You know, these problems were set up to explain nature, but when they can't be explained, well, it's not quite exactly nature, but you know, I'm not like, I'm not wrong. You know, it's like that kind of verbiage. And I mean, because all you'd have to do is have E equals mc squared. You know, if that's your universe. But again, it's the light squared multiplied by the mass. I'm just saying equals the orbital part of the particle effect equals the particle effect equals the electron orbital, not just energy, the polarization. You know, this is what they're talking about. And if that's what the universe is made up of, you know, then you just divide it by 2. You get like the half-life. I mean, because all you have to do is understand that, well, if you can divide, like if it's going in. So I mean, do you see the trouble that I'm having with this right now? How they're never going to have math for the truth, if you want to call it. Like, they're never going to have exact math. So I'm glad I've lived to understand that.